Hello, today I going to talking about vertical order traversal of a binary tree. So here you can see it's hard question, but if you really understand this question, I think this one is straightforward. It's very simple, I think, because here only add one more requirement. Here you see sort needs no binary value. So I will show you what is the difference. So now go through this question and before go through the description, let's see here in the company. So the Facebook, Amazon, Google, Microsoft frequently ask this question. So it's very popular question, I think, in 6 months. And then here we need to the constraint is start from one, so we don't need to check the rule is no because it's not possible. Rule is no because it start from one, right? At least one node in there. Now go to this question. Given the root of a binary tree, calculate the vertical order traversal of binary tree. For each node in position, row, and column, its left and right children will be at position. And here's next node. It's go left and go right, the respective. The root of the tree is at 0, so it's always start from root. And here, the vertical order traversal of the binary tree is a list of top to bottom ordering for each column, index starting from the leftmost column and the adding on the rightmost column. So there may be multiple nodes in the same column, a same node and column. In such case, so needs no binary value. So you can see here. I think the example two is more. It already explained on the detail. So you see the 156 in the same column. So you can see the output is 156. But here, if 65, we need to sort it, right? The 5 should come before the 6 because 5 is less than 6. Now I will show you the, now let me see the solution. Here, I use the BFS and the HashMap to solving this question. So we can create the info class. The class have the two field. Node is maintain the current node and its column. So if we the rule is always start from column 0, right? 0 column, and if we go to left, it's -1. Go to right, it's 1, and here is -2. It should be 0 and the 0, and is 2, right? But this quite if here is 6, for the value is 6, 5. Because we know we will go through need 3 node in the same column, right? But the first node is in the first row. These 2 node in the third row. So 3 always come before the 5, 6. And then if we get a 6, 5, we need to sort it, right? Because these 2 values in the same row. So this one should be we need to sort it in ascending order. So it should be 5 and 6 as our output. So we need to maintain this order. I think it's pretty simple understanding this question, I think. So here here I already show you now step 1, step 2, step 3, and step 4. And here this one is the return type. So we need to return this nested arrays to the vehicle. So we don't need to care about this one. So here in the beginning, we need to initialize. We need to create the root. We need, well, no, we need to create the info object with the root with the 0, the column 0, right? So here should be 3 and 0. Now next step we need to check. We need to go through. We need to pop out this one. when we pop out the 3 from the queue, so this one will count this out from the queue, and then we need to check. Oh, sorry, I forgot to mention here. I create this one because we need to the one should be 6 5. Here you can see here I use the priority queue. We know priority queue can store element in ascending order. Actually, net at most 2 node will be overlap. Cannot be, we cannot find 3 node in the same column and the same row. For example, let me cross this out here. For example, we have the 2 node here with 2 children, 2 left, right child, and then, right. So these two is possible overlap, right, in the same column. So do we think this node will be in the column? No, right? Each row only 2 nodes will be overlap at most. So here you can use 2 variable to comparing, or you can use the priority queue. Is up to you, because I think I'm lazy. I just want the priority queue help me to store element in ascending order. And then when we first step, we need to complete we need to traverse each row, uh traverse each row the owner value in each owner node in the row, right? So when we finish this one, we will get the list with each column, and then pop out to this column. So if we got a 3 will come first. So I will tell you later this one. So here we pop out the 3 from the queue, and we need to check the column 0 in a row or not. We know the 0 is not, the column is not in the row map, right? So we create a key winner pair. We need to create a new key winner pair with the 3. Now, next step, we need to update the minimum and the maximum. So here, sorry, here needs 1 second. The step 3, we need to go to left. The current node needs to check the left children is present in the tree or not. We see here 9 in the tree, right? So we create a new info with the -1 because previous column is 0. So 0, the current node go to left. So here we need to -1. And now we go right A, and here is increased by 1. Now next step, we need to update the minimum maximum. So we know the minimum is -1, the maximum is 1. Why here? Because the questions say we need to keep track of how many color in our map. So we can use this way, and we are using a while loop to go through the -1, 0, 1. We need to go through the column map with this index. The index can easily help us to get each list of each column. And then when we finish this one, first row, we just we need to remove this one, and remove this one. We don't need to here. And then now we go to the step 4. We need to sorry, I removed it 0 with 3, right? And we need go through this low map based on each key, and add to the column. So here should be 3. Now we take this out. Now next step, it, this quite just repeat the question. Now we clean this out. We need get it take this out from queue. So we need to check the negative one in the low map or not. We obviously it's not, right. So we need to create the key. We need to create the key one pair and the negative one with the sorry two it's negative one with the 9, and we need to check go to left children. So we know left children 4 with the negative 2, and the 0 with the 0, right. So we just follow this way, and then we need to finish tennis out too. We also need tennis out, and there should be one obviously one is not present in the row map, so it should be A. And then we also need to check on the left children and right children. So we need to keep updating here, and then we update the minimum and maximum, and then we need to now we go to step 4. We need to get these two lists back. We need to merge these to the column map. So here should be negative 1 with the 9 and 1 with the A. And keep doing this one. And then we go to row, third row, do the same thing here. Just pop up in the first info object from the queue. And then we just do in this way. So pop on this one. So we know negative 1, negative 2 is not present in the row map. So create a 4. And the 0 with the 0. And we also need to also have here still have some node, right. We also need to still need to travel. I don't want to explain too much here. It's just repeating what, and then we need also keep updating the minimum and the maximum. Then we need to merge this row map to the column map. So here we make sure the negative 1 is present in the column map or not. It's not, right. So we just create a new. We just create a key with the list. Now here's not. Now let's go to check here the 0. So let's check the 0 key, 0 column in the column map or not. Yes, yeah, we already have 0, right. So here we just add the value at the end of this. Then so I drawn this. It's not really. I'm not sure. Do you understand? Here's why I saw here is how do I do this question. I think if you understand the previous question, so you need to solving this question first by its premium. So you need to buy. Otherwise, you cannot open and do this question. After you totally understand this one, and then you can totally understand. And the hard question is not hard question. I think maybe it's medium. Now let me show you the coding. So here I create a result. Because you can see the return type is the nested list, and then we use this one to jog out how many columns in our map in this tree, and then we create this one call map and a queue. Initially we need to create an info object containing root with the 0, and then we need to go through. We need to run a while loop. So if queue is not empty, we know we need to break the while loop, right? Here we create a size. Size means how many nodes in the in particular row. And then I also create a row map. So each row with a different column in each row, right? So yeah. So here we need to check which is pop out in the queue, pop on the first info object from queue, and then we check if the current is present in the row map or not. If not, we just create this queue in a pair, and then we just add a value. You can see here is priority queue, so they will help us automatically store element in ascending order. We don't need to do anything. And here we check the node down left icon to know if yes, if true, right? Now we just execute this part, and we create a new info object. And here you can see -1, which means just go to left. And here we need to update the column. Where we start reading the column, where we start reaching the end of column, here go to right. And then when we finish traversing the entire in particular row, then we just need to merge this row map to the column map. So right here, because we make sure we know even though 3, maybe the root value is A, or maybe here, this example, maybe this is not 1, it's A. Even though A is greater than 5, 6, right? But so A should be come before the 5, 6 because A in the first row, right? In the 5, 6 and a third row. So no matter which one you is, so always come before the 5, 6. And then here we need to we need to check the column index is present or not in the code map. If not, we just create an array list, and we just pop up the first info object, the list, and then just go to the list and add value into the particular column. And then finally because here return type is the nested list, right? So here we need to go through the leftmost to rightmost because the question say it should be start reading from left to right column, right? So we use this way, and then we return a race. Let's see what happened here. So you can see, okay, I pass on the test case. The time complexity is B of n. N is the number node in the tree. The space complexity also is B of n. So thank you watching the video. Hopefully you can enjoy my explanation. If you have any issue, just reach out to me. I can explain to you in person over remote.